Okay, let's continue first order systems. Okay, now we want to see the effects of the inputs to the system's response, right? Okay, let's say we have a system's 1 over s plus 1 again. Okay, let's say input is r of s, y of s. Okay, we need to see what is the effects of the inputs to the system response. Okay, so we will supply three different inputs to the systems, which is R1. Look at the slide. R1, the input 1 is 1 over S, R2, 2 over S, R3, 3 over S, right? So we're going to apply to the same system, which is 1 over S plus 1. And then we need to see what is the response, and then the parameters on the response side, right? Okay, you see from the response in the slide, the response represents the input 1 over S. The blue color one is the response for the input 2 of S. And then the yellow color one is the response for the inputs 3 of S. Okay? But you see the response, even though the response looks different, but the parameters such as the the time constants, the settling times, even the rise time, they are the same, right? Because that parameter, that three parameters are actually belong to the system, not to the input. Regardless of any inputs, the response, the parameters will be the same, but the only things that change is the steady state. Okay, the steady state will change according to the inputs. If the input is higher, the steady state will be higher, right? Okay, let's see this. I'm going to show you very quickly. So it is, we have three inputs, R2, R3, okay, 3 of S. So we're going to input this to the system's RS, then we need to see what the parameter will change, right? So, so Y of S, that will be 1 of S. So this is our R of S. Then our system would be 1 minus 1 e to the t. Okay. So you see there is a minus t, this is a 1t, right? That 1t, right, actually taken from here. No, taken from here. 1 over 1 here. Okay? Taken from there. Okay, then we'll have this one. Let's represent the response, the red color response. Alright? Then if we apply 2 of S, right, the same thing, that will be 2 minus 2e to the minus 1t, right? So if we calculate, we're going to, in term of the t tau, time constant, rise time and settling time, they'll be the same, right? And try 3 of S, 1 over S plus 1 is 3 minus 3e to the minus 1t, right? So all these three actually will produce the same response, but different in steady state, right? So meaning that by looking at the transfer function here, right, we should be able to determine the time constant, rise time, and settling time. right? Without having to convert to this time domain. Okay, what we're going to do is that, okay, whatever transfer function that we have here, regardless of any inputs, we can find these three parameters, right, from here. So what we're going to do is we're going to convert this into a standard first order system, which is tau plus 1. Okay, this is a standard form of first order system. Okay, standard form of first order systems. Alright, so we have that. Then whatever transfer functions that we have, we're going to change to this form. Okay, for example, if we try to do this one first, okay, because the important here is we need to find the tau, and then once we know the tau, we can find the rise time, we can find the settling time. Okay, so because from the previous example, right, we know that 1 of s plus 1, whatever input that we supply here, we will get the tau equal to 1 second. Settling times is equal to 2.2 seconds, and this rise time. Settling times is equal to 3.91 second, right? All right. Because of this, okay. If we assume that this is our tau, which is considered 1, this is 2 tau, 3 tau, and 4 tau, right? This is our response. Because we know that the t equal to 1 is here, which is 63.2%. Okay? And then we know that the rise times is somewhere 2.3 here to 0.1 here, which is 0.1 t. In this case, this is 2.3 t. So we can find that t r equal to 2.2 tau. So this is tau, right? And then tr 2.2 tau, regardless of any transfer function, ts will be somewhere here, 3.91 tau, right? So because settling time is anything that above 98%, we consider that is a time that is the where the response is at steady state. So we can use this 3.91 tau as a settling time, or we can simply put 4 tau. Okay, so this is the formula that we have, right? So next time when we have a different transfer function, we can simply calculate regardless of any inputs, and then we don't have to. Very important that we don't have to convert them into the time domain as we did before, right? Okay, so you see from the slide there are 3 responses, and then the first one is 1 over s, second 2 over s, and the third one is 3 over s, the input. But the time will be the same, right? So the system doesn't change, the system response doesn't change the parameter of the first order systems, but it rather change the steady state only, right? Okay, now